This is part 4 of 8086 assembly language programming, and we will see how we can process arrays in assembly programming. So arrays are contiguous memory locations, and the locations can be either bytes or words. So we will consider a typical case of array processing. We will just store 9 numbers in an array, and then we will perform an operation like incrementing each element of the array. So suppose that these are the elements of the array. So 2, 1, 3, 4, then the sequence up to 9. Okay, and our purpose is to change this array in situ, that is in that place itself, in value to 3, 2, 4, 5, likewise up to 8, that is 10. So this is a sample arrangement of the array. Suppose that the array is stored in segments 0, 1, 0, 0 at offset starting at 2, and suppose that the array terminates over here, okay, in the offset 12. So you can see here that it's a word oriented array. So for each entry 2 bytes are reserved. Okay, so our first element, as you can see here, it's 2, second is 1, third is 3. So 2, 1, 3, 4, likewise up to 9, it's there. So this is the array that we are going to process. Then what happens after we do the operation, that is incrementing each element by 1, we will get this array. Okay, instead of 2 we will have 3, then instead of 1 we have 2, then instead of 3 we have 4, likewise instead of 9 we will have 10. Okay, so this is the final array that we wish to have. So let's see what is the probable structure of our program. So like all procedure oriented programs, we will actually do a procedure. Okay, to do this operation, we will first have declaration of code and data segments. Alright, so we will have in data segment label storage will be there. Obviously we will be storing our array over here, or we will be writing statements to create our array over here. Then within the code segment we will first initialize the parameters for the procedure invocation. Then we will invoke the procedure, and then we will have a process termination statement, then the procedure body. Okay, as you might be remembering from the previous video, this should be the structure followed within the code segment, because once after initialization, when the procedure is invoked and procedure terminates, we are actually expecting the code to close, right? So a process termination coding should be here, then the procedure body. Why? Because we are trying to avoid a fall through. Okay, after the invocation of procedure we will actually branch over here, then after the procedure's execution we will continue with the line just after procedure invocation, then we will go for termination, then we have to jump over the end of the program. Okay, we don't expect to repeat the procedure once it is called without proper invocation. So we will see the overall structure of the program to increment elements of an array. So this is the segment initialization part, where we'll just name the segments. Then we have some EQ statements. Okay, we will get to that soon. Then we have the entries to be kept within the data segment. Okay, so this test array is our array to be used, or the initial array. Then we have the code segment, where you can see that initialization of the parameters to be passed to the procedure, which is array inc, is done here. And then the array inc procedure follows just after the process termination statement. So note that we have the initialization part first, then the array invocation, followed by process termination statements, then the body of the procedure. Okay, soon after the body of the procedure, the code segment ends. So this is the general structure of the program. We will analyze the assembly code and see how it works. As usual, we will define code and data as labels for code segment and data segment, and will arrange it to be loaded with the start address of the code and data segment respectively. Okay, so that is done using SU. Now we are using a new directive, that is EQU, here to actually label some constants over here. So you know that we are considering an array of 9 numbers, right? So the array size is 9 or 9h. So instead of using 9 in our code, what we do is we will equate the constant 9 to a label array size. So wherever we use array size within the code, assembler will replace the label array size with the value 9h or 9. So note that this EQU directive is used outside the data segment, it's not used within data segment. So it means that it is just a substitution. Okay, no storage space is allotted to these labels array size or add number. Okay, so add number here refers to 1, or the number that we are going to add to each and every element of the array. Okay, so the advantage of using such a method is, suppose we need to change the number of elements in the array, so you can just update the constant at one place over here. And similarly, if you need to increment every element of the array with maybe a constant like 3 or 5, so you can just change it over here. Okay, rest of the code will work fine. So that is the advantage of using EQU. Then as usual, we have a data segment declaration over here. So within the data segment, we will just define our array. Okay, so array is defined using the label test array. Okay, and the operator DW, that is define word. So for each element of the array, a word space, that is 2 bytes, will be allocated. So here declaration of the space or creation of space for the array elements as well as the array elements are listed. So that's what we need to note here. So test array just indicates the beginning of this array. So test array is a label which points to the address or location of the first element of the array, that is 2h. Okay, so if you do test array plus 2, we will land at the location of 1h. Test array plus 4, we will land at the location of 3h likewise. Okay, so effectively in the code we are actually pointing to the starting location of the array, and then we will increment the address pointer so that we may reach or go through the individual elements of the array. Okay, so that's the declaration of data segment. Now we will see the code segment. So in code segment, what we do is we actually will need to pass the parameters to our array increment procedure. Okay, so we are using a procedure. So as we saw in last video, the parameters to the procedure are passed using stack. That is one method. So we already know that the beginning of array is indicated by the label test array. So that offset of the array is taken, put it in x, and we push the value to x. So if you see here, this test array value, right, or the address of the first array element is pushed into stack. Now the next thing is we need to also pass the number which has to be added with every element of the array. Okay, so that is add number. So what we do is add number is a storage area. The number to be added is present, so that is moved to x and that value is pushed. Similarly, array size is the number of elements in the array. So again that is pushed into stack. So in the stack, what you can see here is these three parameters are pushed and ready. Now we are calling the increment array function or array increment procedure. So when we do a procedure invocation, we know that the return address or the address of the next instruction will be automatically pushed, so that return address is also pushed. So this is the stack frame of this main procedure or the main portion of the code segment which initializes and transfers control to array increment procedure. Okay, so this is the final stack frame, right? And then now we will branch to the array increment procedure. So if you see the array increment procedure, as we do usually, right, we need to construct a stack frame for the procedure on top of the stack frame of the main procedure. So this is the main part that we have seen earlier, right? This is the main stack frame. Over that we need to construct stack frame for the array increment procedure. So as usual, we will push the current BP pointer onto the stack. Now we will load the BP to point to this location, so that will be the base of this new stack frame. Now whatever registers we are going to use in this procedure, we will just push it into stack for preservation. So AX, BX, CX and DX is pushed, as you can see over here. Now we need to access the parameters required for this procedure to run. So the parameters required are the starting address of the array, the element to be added to each element of the array, and the number of elements in the array. Okay, so that we will access using indirect addressing. So BP, right? BP is now currently pointing over here. So the size of the array, it is located 2 words from BP. Not 2 words, yeah, 2 words. So effectively it means 4 bytes from BP. So this is actually 2 bytes, then 2 bytes, so array size can be reached by BP plus 4. Similarly, the constant to be added is over here, so we have to move what, 1 2, we have to move how many locations here? We will move 2 words, now 2 words, now 2 words, so effectively you have to move BP plus 6. Now again, if you move BP plus 8, right, it is 2 4 6 and 8, we will reach the location where the start address of the array is stored. Now these values will be moved to appropriate registers CX, AX and BX. Now we are going to proceed to our operation. So our operation is get the first element from the array, right? So using indirect addressing, you know that BX is having the start address of the array. So using indirect addressing, the first element of the array is moved to DX. Now using add DX commands, what we will have? We will have the value in AX. The value in AX is the number to be added, this is 1. So 1 is added to the first element of the array. Now we have to move this updated element to its actual position. So we already know that BX points to BX contains the address of the first element of the array. So using indirect addressing, the updated first element is moved back to its original position. Now what we need to do? We need to proceed to the next element of the array. So each array element, as we have seen earlier, is a word sized element. Okay, so we need to move 2 bytes to get to the next element. So BX is currently pointing to the first element of the array. So the next element can be found out by adding, or the location of the next element can be found out by adding 2 bytes to the value in BX. So BX plus 2 will leave or give us the address of the next element to be processed. Now we will just loop to this point. So what happens is the number of elements of the array is loaded in CX, right? CX will be decremented by 1. So what will loop do? We already know the action of loop. Loop will jump to the labeled location given as argument in the loop, provided CX is not 0. Okay, so before jumping it will decrement CX and it will check whether it is 0 or not. Then it will perform the jump. So here we will jump over here. So again the action is to get the element pointed to by the address in BX. So now BX is having the address of the second element of the array, and we will move it to DX. Then the number to be added is stored in AX. So the second element will be updated. The updated value will be in DX. Now the value in DX will be moved to the second element's location in the array. Likewise, this will repeat until all the elements of the array are processed. Okay, now what happens? We will pop all the registers before leaving this procedure. Okay, so if you see here DX, CX, BX and AX were pushed, right? So all those things will be popped. Then also the return address too will be popped to the instruction pointer. Then only we will be able to return to the main portion of the code segment. So that is also popped. So while we leave this array increment procedure, this is the status of the array. Okay, now the stack frame constructed for the procedure is actually removed. Now the only stack frame remaining is the stack frame of the original section of the code segment which called or invoked the array increment procedure. Okay, so we are now jumping back to the point where we invoked the call. So if you see here, the only thing remaining is termination of the procedure or termination of the entire code. Note that in the current stack frame we already have array size, add number and test array or the address of the starting location of the array pushed or in the stack frame. We are supposed to actually pop these things, but as we are not proceeding further, what we are doing is instead of popping we are just terminating. Actually, as a good coding practice, whatever you pushed you should pop it. Okay, so we are having 3 things pushed into the stack frame, right? These are remaining in the stack frame. So before actually invoking this part you should actually have popped it, but we are not popping it because we are not proceeding further. So we will just terminate the process. So that marks the end of this code.